This video is Trig Notes 6.2. It's going to be an introduction to conics, and specifically the one type of conic we're going to talk about is going to be the parabola. Conics in general are, there's really four of them that we're going to be talking about in these next few sections. We're going to be talking about circles, which is a type of conic. We're going to be talking about parabolas, and that's going to be the main topic for this specific section. We're going to be talking about an ellipse, how we graph ellipses, and then finally how do we graph hyperbolas. So those are going to be the four different types of the equations that we're going to graph. And again, today's topic is going to be focusing on parabolas. So let's take a look at an example. Here's a parabola. It's a U-shaped graph. We're going to be talking today about when the parabola opens up and down, as well as if we have a parabola that's opening left and right. There's a couple of key terms that we need to talk about when we're dealing with the parabola. Okay, so let's first talk about this. The parabola is all of the points. The parabola is all the points that are the same distance from a fixed point, and that fixed point is going to be the focus, and a fixed line, which we'll call the directrix. So we've got a focus here, and we've got a directrix here. And what we're going to notice about the focus and the directrix is that they will be the same distance from the vertex. So this distance right here, we're going to call that distance P. To find then the directrix, you would go this distance of P. But since you're going down, we would say that's negative P, and you're going up, and that's positive P. Okay? And then we would we'd make our parabola from there. So the key terms we need to know is the focus and the directrix. What I want you to pay attention to is that with the focus, you'll notice that here's my focus, my graph is wrapping around the focus. So for a parabola, it will wrap around the focus. So the graph will always wrap around the focus. So if you have a graph like this, and you know your focus is over here, let's say, then your graph will wrap around. It could be like that. All right, and we'll get more specific. We'll get into the specifics about that in just a moment here when we look at the two different types of equations. But key terms are going to be the focus, the directrix. The directrix is going to be this line here that is going to run where it will not touch the parabola. So it's going to be running, if you want to think about it, parallel to the parabola. And you have your focus, which is going to be the graph is going to wrap around, and your vertex, which will be the key point for graphing your parabola. Let's take a look at the equation now. So we're going to be talking about two different types of parabolas. Those parabolas that open up and down, which is what we're used to seeing. So for example, it would look something like this, a parabola that opens, or maybe a parabola that's opening downward like this. Okay. If that's the case, if our parabola is opening up and down, or down I should say, then we use this form of the formula. X minus h squared equals 4p times y minus k, where hk is the vertex, p is the distance from the vertex to the focus. It says directional distance, that means whether it's positive or negative. If p is positive, it's opening up. If p is negative, it's opening down. And like I said, hk is the vertex, p is the distance from the vertex to the focus. The other equation that we're going to use is going to be this form. Y minus k squared equals 4p x minus h, where we have the same idea here, that the vertex is going to be the hk, p is the directional distance from the vertex. This case, if p is positive, it's going to be opening right, and if p is negative, it's going to be opening left, because our parabolas will look like this. They'll either open this way, or they'll open maybe this way, left or right. Again, so these are going to be our formulas, and these formulas will really start to make sense once we look at an equation and how we start to use these formulas. Keeping in mind that the really difference between the two is where the hk is and what values are being squared. So when you see the x that's being squared, that's your sign to let you know that it's opening either up or down. If you see the y value that's being squared, that's your sign to let you know that it's opening left or right. Alright, so taking a look at this next example, it wants you to actually make the graph of x squared minus 4, or minus 10y equals 0. So right away, I'm going to identify whether this is opening left or right, up and down. So I ask myself, which term is being squared? Since it's x squared, that tells me then that I should be using the form, again looking at the front side of my notes here, I'm using this form of the formula. Okay, and this form, when the x value is being squared, tells me that it's either going to open up or down. And that's important again to keep in mind. So I need to make this look like that. In other words, the x squared term is all by itself, everything else gets moved over to the other side of the problem. So doing that, keeping the x squared by itself, we're going to get rid of the 10y by adding it. So now, this is going to be my x minus h quantity squared, so this is really an x minus 0 quantity squared. This is my 4p times y minus k. So really what I have here is I have 10 times y minus 0. That's another way of writing that so I can see what my h and my k are. So looking at this, I can see that my hk, because that's something I need to know to be able to graph this, is 0, 0. So let's put a dot there for my vertex. Remember, hk stands for your vertex. And then, looking at the standard form of the formula, the 4p is what's being multiplied outside of the y minus, in this case, the 0. So this is the 4p. Let's do a little solving to figure out what p is. I know that 10 is what 4p is equal to. So I can write that equation. If I solve this for p, I would end up getting p to be 2.5. And since p is positive, that tells me it's not going to open down, it's going to open up. So a positive p means it's going to open upward. So what I want to do is, from my vertex, put a v there for vertex, go up, since it's opening upward, 2.5. So that would be right about here, and that's my f for my focus. Go down 2.5, and that would be my directrix. Now remember, my directrix is a line. It's either a horizontal or a vertical line depending on how my graph looks. So since my parabola is going to wrap around the graph like so, because again the parabola wraps around the focus, then I can find my directrix then just by making I'm going to make it a dashed line by making it this way. Now your goal to keep in mind when you're making your graph, okay, once you figure out whether it opens up or down and where your focus is when you wrap it around, you try to keep the distances between the f and the line all to be about 2.5, because that's my distance, that's my p-value. Again, this value right here is p, and that's 2.5. So try to keep it the same. The bigger the distance is, the wider then your graph is going to be when you actually make this graph. Let's think about graphing this one, y squared plus 5x equals 0. So it's the y value that's being squared, so I know the generic form is this form, and that means that it's going to open either left or right, depending on what my p-value is. So let's get this to have the y squared by itself. So we would subtract the 5x to move it over. So now filling this in, this really looks like y minus 0 squared equals negative 5 times x minus 0. Again, I'm writing it like that because I don't have an hk for this problem. It's 0, 0. That's my vertex. So we'll plot that. But it's helpful to write it like this, so now you can see that the 4p is what was being multiplied by the x minus the h. This is my x minus my h. So this right here, this negative 5, is what 4p is equal to. So negative 5 is equal to 4p. We divide by 4. We end up getting p to be negative 1.25. That's going going to be important for us to know, since P is negative, that means our graph is going to be opening then to the left. How do I know that? Well, if I graph this, if this is V, P is negative 1.25 would be right here. The graph wraps around the focus like so, so it has to open to the left, since the focus is to the left of the vertex here. So it opens to the left. Now the only thing I need to do is put the directrix on. So since it's opening leftward, I move 1.25 to the right to put my directrix. And again, it's got to go as a vertical line here because it will not touch the graph. So that is the directrix. So when you graph these, you need to plot the V, plot the F, and show the directrix as well. Okay, so instead of now having an equation, we're going to have to come up with the equation for what the parabola would look like. So let's actually plot what we know. We know our vertex is at 0, 0. Let's put a V there. Our focus is at 2, 0. So our focus is here at 2, 0. Now remember, I said that the graph will always wrap around the focus. So that means that my graph has to be opening right like this. So if it's opening right, okay, go back to the front side of your notes and check to see which form of the formula has it opening right. And that would be this form, where the y value is being squared. Okay, so to get this, you need to kind of draw a visual to understand that it's opening to the right. Now plug in what you know. Well, here's what I know from my graph. My HK is 0, 0. So I can put a 0 in here, and I can put a 0 in here. Okay. I also know from my graph that P is the distance from vertex to focus. So this P is, since it's opening right, that would be a positive 2. So if P is positive 2, let's put a 2 in here. Let's fill that in. Y minus 0 squared equals 4 times 2 times x minus 0. I don't really need to have this minus 0. And 4 times 2 is 8. And again, I don't really need to have this x minus 0. I can just leave it as x. So my equation that will open to the right and have a vertex and focus of the given points would be y squared equals 8x. I'm going to recommend, whenever you're trying to write an equation for a parabola, to make a quick sketch of what you're given so you can visualize which one of the forms that you need to use. Again, I knew I had to use the y squared version because it opened to the right. And I don't really see that unless I actually make a quick sketch of this graph. So keep that in mind when you're trying to write the equations. Make a quick sketch. So keeping that hint in mind that I just said, let's make a quick sketch of what I'm given. Vertex is at 3, 2. Focus is at 1, 2. Again, when we label these, let's put F's and V's next to them. So now I know that my graph is opening to the left. So when my graph opens to the left, I use the form where the y value is being squared. So let's write that form down. And again, what I need to know is I need to know my vertex, my HK, and I need to know my P value. So my HK now, I've moved away from 0, 0, is the vertex, it's 3, 2. Okay, it's this point right here. The focus is the distance from vertex to focus. The P value is the distance from vertex to focus. This distance is a 2, but because it's opening left, that means that that's a directional distance, that's a negative 2. So plug in what you know. Y minus 2 squared equals 4 times negative 2 times x minus 3. The only thing that you need to do here is you don't have to FOIL this, you want to keep it in this form. The only thing you have to do to write your equation here is write this as a negative 8 times x minus 3. So this would be my formula, or my equation for the parabola that has a vertex of 3, 2 and a focus of 1, 2. Again, keep in mind when you're doing finding your P value that it's a directional distance. When it opens to the left, it has to be negative. When it opens to the right, it's positive. If it was opening upward, it'd be positive. If P was going down, P would be negative.